Hello, this is the third video of a fourth Matrices series for OCR AS Core Pure Further Mathematics. It covers finding the inverse of a 3x3 matrix. One idea you may already be familiar with is that of writing down the transpose of a matrix. So the transpose is the matrix obtained by interchanging the rows and columns. As an example here for A and A transposed. We have covered how to find the determinant and cofactors in previous videos. Now we will use these as part of the process of finding the inverse of a 3x3 matrix. The first step is to find the determinant of a matrix, remembering that if a determinant is 0, then no inverse exists, i.e. the matrix is singular. The second step is to find the cofactor of every element of a matrix. Remember, the place signs when finding cofactors do not tell you the sign of the cofactor, but whether or not you need to change the sign of the minor in obtaining the cofactor. The third step is to replace each element with its cofactor, in other words, to set up a cofactor matrix. We then take the transpose of this cofactor matrix, which is called an adjugate or adjoint matrix. You do need to find the cofactors in the same way as we saw in previous videos, but for each element, not just for one row or column. The final step is to divide this adjugate or adjoint matrix by the determinant, and that then gives us the inverse matrix. Here is an example where we need to find the inverse of M. First of all, we need to check the determinant is not 0. So, determinant of M, and I'm going to expand by the first row. It doesn't really matter, but there aren't any zeros, so I can choose any row or column to define the determinant. So it will be 1 times that determinant of -2 minus 12. Obviously we did the details of how to find a determinant in the previous video. We're then doing a minus 4 using the signs from the sign matrix, and that determinant will be -4 minus 16. And then finally a plus 2, 6 minus 4. When I sort that out, it should give me a minus 90, which is not 0. Therefore I know that an inverse exists. I would then go on to work out the cofactors for each element. You may wish to pause the video and check these for yourselves. These cofactors I will now put together in a matrix called the cofactor matrix. I will then transpose that cofactor matrix to give me the adjugate. And finally, I will divide by the determinant to give me that inverse, written as m to the -1. You may wish to pause the video now to either check the inverse using your calculator or by multiplying manually with m to make sure you get the 3x3 identity matrix as a product. In this example, you would have to find the inverse manually because you have got a variable k, and therefore you wouldn't be able to just use your calculator. Your first step, of course, would be to look for the determinant of A, and this should work out to be 2 minus 2k. You may wish to pause the video to try that step for yourselves now, remembering that they are expecting you to give your answer using k. Your next step is to find the cofactor for each element, again using k. So the matrix C written here is the cofactor matrix. This is then transposed to be CT, and finally we write the inverse a to the minus 1 by dividing CT by the determinant. This may look a little more complicated because of the use of k and the expressions and the elements rather than just numbers, but it is exactly the same process as we have used in this and the previous 2 videos. This is the final video of a 4th Matrices series.